Hello viewers, welcome to my channel Maths with VTC. Today we are going to see elimination method in the third chapter, pair of linear equations in two variables. First let us see the procedure. Step 1. First multiply both the equations by some suitable non-zero constants to make the coefficients of one variable numerically equal. It may be coefficient of x or coefficient of y. By suitably multiplying, we have to make them equal. Step 2. Then add or subtract one equation from the other so that one variable gets eliminated. If you get an equation in one variable, go to step 3. What are the other possibilities? If in step 2, we obtain a true statement involving no variable, then our conclusion is the given pair has infinitely many solutions. If in step 2, if we have a false statement without any variable, then our conclusion is the given pair has no solution. That is, the given pair is inconsistent. Now let us see this step number 3. Solve the equation in one variable, so obtain to get its value. Step 4. Substitute this value of x or y in either of the original equations to get the value of the other variable. So elimination method is comparatively simple than graphical method and substitution method. Now let us see an example. 8. The ratio of incomes of two persons is 9:7 and the ratio of their expenditures is 4:3. If each of them manages to save rupees 2000 per month, find their monthly incomes. So read this problem carefully. We are given only the ratios. So let us denote the incomes of two persons by rupees 9x and rupees 7x and their expenditures by rupees 4y and rupees 3y respectively. In order to maintain the ratio 9:7, I have taken the income as 9x and 7x. In order to maintain the ratio of expenditure 4:3, I have taken the expenditure as rupees 4y and rupees 3y respectively. So in this place, you have to be careful how to assume the variables. Now, consider the first person. His earning is 9x, his expenditure is 4y. Therefore, 9x minus 4y is equal to rupees 2000 because his saving is rupees 2000. Therefore, 9x minus 4y is equal to 2000. For the second person also, saving is rupees 2000. Therefore, 7x minus 3y is equal to 2000. Now, multiply the first equation by 3 and the second equation by 4 to make the coefficients of y equal. So we get 27x minus 12y is equal to 6000. 28x minus 12y is equal to 8000. Now you see the coefficients of y are equal. Both are minus 12 only. So what I do, I subtract one equation from the other. Actually, I subtract equation 3 from equation 4. So I get x is equal to 2000. Substituting the value of x in 1, we get y is equal to 4000. Now we can find the incomes of both the persons. Since x is equal to 2000, income of the first person is 9x, therefore it is rupees 18,000. Income of the second person is 7x, therefore it is 14,000. Now you can verify this. 18,000 is to 14,000 is equal to 9:7. Now expenditure ratio 18,000 minus 2,000 is to 14,000 minus 2,000, which is equal to 16,000 is to 12,000, which is equal to 4:3. Hence, verification is done. Example 9. Use elimination method to find all possible solutions of the following pair of linear equations. 2x plus 3y is equal to 8, equation number 1. 4x plus 6y is equal to 7, equation number 2. Now I want to make the coefficients of x equal. So for that I multiply equation number 1 by 2 and equation number 2 by 1. So after multiplying equation 1 by 2, I get 4x plus 6y is equal to 16. I write equation 2 as such because I am multiplying it by 1. Therefore, 4x plus 6y is equal to 7. Now you see the coefficients of x are equal. Both are 4 only. So I subtract one from the other. So I get 4x minus 4x plus 6y minus 6y is equal to 16 minus 7. That is 0 is equal to 9, which is a false statement. So what is our conclusion? The given pair has no solution. Very simple. Example 10. The sum of a two-digit number and the number obtained by reversing the digits is 66. If the digits of the number differ by 2, find the number. How many such numbers are there? So you understand the problem carefully. So I take x as the 10th digit and y as the unit digit. So what is that number? Because x is the 10th digit and y is the unit digit, that number is 10x plus y. It is in the expanded form. Suppose the number is 56, then 10 into 5 plus 6 is 56. When the digits are reversed, x becomes the unit digit and y becomes the 10th digit. Therefore, the value of number is 10y plus x. For example, 56 is reversed, we get 65, which is equal to 10 into 6 plus 5. For understanding, it is given. Now, what are the relations? 10x plus y plus 10y plus x is equal to 66. When you simplify, you get 11 into x plus y is equal to 66, or x plus y is equal to 6. You call this as equation 1. We are also given that their difference is 2. Therefore, x minus y is equal to 2 or y minus x is equal to 2, because we do not know which number is bigger, x is bigger or y is bigger. So, we will get two equations, x minus y is equal to 2 or y minus x is equal to 2. So, now we solve either 1 and 2 or 1 and 3. If you consider x minus y equal to 2, then solving 1 and 2, we get x is equal to 4 and y is equal to 2. Therefore, the number is 42. If we consider y minus x is equal to 2, then solving 1 and 3, we get x is equal to 2, y is equal to 4. Therefore, the number is 24. Thus, there are two such numbers and they are 42 and 24. You can easily verify that. Next, exercise 3.3, problem number 1. Solve the following pair of linear equations by elimination method and the substitution method. So, this equation is to be solved by both the methods in order to compare which one is easy. Let the equations be x plus y is equal to 5. You call this as 1, and 2x minus 3y is equal to 4. You call this as 2. Elimination method. So, first equation is multiplied by 2 and the second equation is multiplied by 1 in order to make the coefficients of x equal 2x, 2x. Therefore, we can subtract one equation from the other. Actually, I subtracted 4 from 3. So, when I do it, I get 5y is equal to 6 or y is equal to 6 by 5. If I put this value of y in equation 1, I get x plus 65 is equal to 5 or x is equal to 19 by 5. Hence, the solution is x is equal to 19 by 5, y is equal to 6 by 5. So, this is done by elimination method. Now, let us see substitution method. From equation 1, x is equal to 5 minus y. Substituting this in equation 2, we get 2 into 5 minus y minus 3y is equal to 4. When you reduce it, you get y is equal to 6 by 5. Again, putting this value in equation 5, we get x is equal to 19 by 5. Thus, the solution is x is equal to 19 by 5, y is equal to 6 by 5. So, both the methods are used to solve the given pair of equations. Now, the second problem. Let 3x plus 4y equal to 10 as equation number 1 and 2x minus 2y equal to 2 as equation number 2. Now, elimination method. I multiply the second equation by 2. So, I get the coefficient of y as minus 4. Therefore, the coefficients are numerically equal. First equation it is plus 4, second equation it is minus 4. So, they are numerically equal. When equation 3 and 4 are added, we get 7x is equal to 14 or x is equal to 2. Putting this value of x in equation 1, we get y is equal to 1. Therefore, the solution is x is equal to 2, y is equal to 1. This is elimination method. Now, we move on to substitution method. So, from equation 2, x is equal to y plus 1. You can cut out 2 on both sides, then you get x is equal to y plus 1. Substituting this in equation 1, we get 3 into y plus 1 plus 4y is equal to 10. After simplification, we get y is equal to 1. Putting this value in equation 5, we get x is equal to 2. Hence, the solution is x is equal to 2, y is equal to 1. Now, third problem. You take 3x minus 5y minus 4 is equal to 0 as equation number 1 and 9x minus 2y minus 7 equal to 0 as equation number 2. Now, to eliminate x, I multiply equation number 1 by 3 and equation 2 by 1. Therefore, the coefficient of x becomes 9. In both the equations, it is 9. So, 9x minus 15y minus 12 is equal to 0. 9x minus 2y minus 7 is equal to 0. So, when you subtract equation 4 from 3, we get minus 13y minus 5 is equal to 0 or y is equal to minus 5 by 13. Putting this value of y in equation 1, we get x is equal to 9 by 13. Hence, the solution is x is equal to 9 by 13, y is equal to minus 5 by 13. The same problem is solved using substitution method. Let us see how. From equation 1, what is x? X is equal to 5y plus 4 divided by 3. Substitute this value of x in equation 2, then we get 9 into 5y plus 4 divided by 3 minus 2y minus 7 is equal to 0. When you simplify, you get y is equal to minus 5 by 13. Putting this value of y in equation 5, we get x is equal to 9 by 13. Hence, the solution is x equal to 9 by 13, y is equal to minus 5 by 13. Now, second problem. Form the pair of linear equations in the following problems and find their solutions if they exist by the elimination method. Now, read the problem carefully. If we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. It becomes half if we only add 1 to the denominator. What is the fraction? So, we have to find the fraction. A fraction has a numerator and a denominator. So, I take the numerator as x and the denominator as y. Then we are given x plus 1 divided by y minus 1 is equal to 1 and x divided by y plus 1 is equal to 1 by 2. When you cross multiply and simplify, you get the equation x minus y plus 2 is equal to 0 as equation number 1 and 2x minus y minus 1 is equal to 0 as equation number 2. Subtracting equation 1 from 2, we get x minus 3 equal to 0 or x is equal to 3 because already the coefficients of y are equal, numerically equal. Therefore, I simply subtract 1 from 2, I get x is equal to 3. Putting this value of x equal to 3 in 1, we get y is equal to 5. Thus, the required fraction is 3 by 5. Second problem. 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. How old are Nuri and Sonu? Similar problem we have solved many times. So, we assume x and y be the present age of Nuri and Sonu respectively. Therefore, 5 years ago, their ages will be x minus 5, y minus 5. But we are given x minus 5 is thrice y minus 5. Therefore, x minus 5 is equal to 3 times y minus 5. When you simplify, you get x minus 3y plus 10 equal to 0. You call this as equation 1. 10 years after, their ages will be x plus 10, y plus 10. The relationship is twice. Therefore, x plus 10 is equal to twice y plus 10. When you simplify, you get x minus 2y minus 10 equal to 0. You call this as 2. Now, to eliminate x, I subtract equation 2 from equation 1 because already the coefficients of x are equal. So, we need not multiply by any suitable number because already they are equal. Coefficients of x are equal. So, when you subtract, we get minus y plus 20 equal to 0 or y is equal to 20. Putting this value in either 1 or 2, we get x is equal to 50. Hence, Nuri is 50 years old and Sonu is 20 years old. Problem is very simple. Third sum. The sum of the digits of a two-digit number is 9. Also, 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. So, you read the problem carefully. I take x as the 10th digit and y as the unit digit of the required number. So, what we are given, x plus y is equal to 9. Sum of the digits is equal to 9. So, x plus y is equal to 9. Next, when the number is multiplied by 9, it is twice the number reversed. Reversed number is 10y plus x. So, what is the relation? These two numbers are equal. Therefore, 90x plus 9y is equal to 20y plus 2x, or 8x minus y is equal to 0. So, we get two linear equations. Adding 1 and 2, we get 9x is equal to 9 or x equal to 1. Putting this value of x in 1, we get y is equal to 8. Therefore, the required digit is 18. You can easily verify this also. Fourth problem. Meena went to a bank to withdraw rupees 2000. She asked the cashier to give her rupees 50 and rupees 100 notes only. Meena got 25 notes in all. Find how many notes of rupees 50 and rupees 100 she received. It is an interesting problem. We have to find the number of 50 rupees and 100 rupees notes. So we assume x be the number of notes of rupees 50 and y be the number of notes of rupees 100. Obviously, x plus y is equal to 25. X plus y is equal to 25 because he got 25 notes in all. Next, their summation is rupees 2000. Therefore, 50x plus 100y is equal to 2000, or x plus 2y is equal to 40. Divide both sides by 50. You get x plus 2y is equal to 40. Now, already the coefficients of x are equal. Therefore, directly you can subtract 1 from 2. We get y is equal to 15. So, when y is equal to 15, automatically 1 gives x is equal to 10. Therefore, the solution is 50 rupees note is 10 and 100 rupees note is 15. Fifth problem. A lending library has fixed charge for the first 3 days and an additional charge for each day thereafter. Sarita paid rupees 27 for a book kept for 7 days, while Susi paid rupees 21 for the book she kept for 5 days. Find the fixed charge and the charge for each extra day. So, we have to find out the fixed charge and per day charge beyond 3 days. So, we take x as the fixed charge and y as the charge per day beyond 3 days. So, what is given? For 7 days, she has paid rupees 27. Therefore, it is fixed charge x plus after 3 days, she kept the book for 4 days. So, per day charge is y. Therefore, the charge is 4y. So, total x plus 4y is equal to 27. Similarly, she kept the book for 5 days. Therefore, for 3 days, the fixed charge is x and the remaining 2 days, the cost is 2y. Therefore, the total charge is x plus 2y is equal to 21. Now, you look at the equation 1 and 2. Already, the coefficients of x are equal. Therefore, you can subtract 2 from 1 to get 2y is equal to 6 or y is equal to 3. When y is equal to 3, you can easily find that x is equal to 15. Hence, the solution is fixed charge is rupees 15 and the extra charge per day after 3 days is rupees 3. So, it is a simple problem. Only thing you have to understand the concept. You have to construct the equations carefully. When you construct the equations correctly, the answer also will be correct. Thank you viewers for watching my video. We will see in the next video class.